Alright, so in this second lesson, what we're going to do, we're going to go outside to have a look at the effects of gravity on different objects. So the aim of the experiment is to investigate the relationship between the mass of a falling object and its acceleration due to gravity. So gravity is an important force. It pulls us down to the Earth so we don't float. It keeps the moon in orbit around the Earth, and it also keeps Earth in orbit around the sun. Gravity even pulls stars together to form galaxies. Gravity is a non-contact force. So other types of non-contact forces that you might be aware of, magnetic forces, electromagnetic forces, those are types of forces that there's no physical contact between two things causing the force. So there's no string that's holding me to the Earth, pulling me towards it. It's a non-contact force. This means that it acts on you even when you aren't touching anything. It's an attractive force that acts between two masses. Every object exerts a gravitational force, but it's so weak that you can't feel it. So I think I said this last lesson to you guys. Me and that bin over there, we're attracted to each other. Alright, that bin has a gravitational force towards me, and I've got a gravitational attractive force towards that bin. But that bin doesn't come flying towards me because the force is tiny. Alright, it's a really, really small force. So, gravity obeys Newton's second law, just like other forces. This law states that force is equal to mass times acceleration, so we've already spoken about this. The acceleration due to gravity on Earth is constant, and again, we've spoken about this value, 9.8 meters per second squared. So what does that mean? If I have an object and I drop it, it will accelerate towards the ground at 9.8 meters per second squared. Now that's on the assumption that there's no what? Air resistance. Because we know in practice that if I've got a bowling ball and a feather and I drop those at the same time out off the balcony in Turon, those two things are not going to be accelerating at the same rate towards the floor, are they? No. The bowling ball is going to be accelerating a lot quicker because air resistance is having a greater effect on that feather. So, when objects have been dropped, the only two forces acting on them are gravity and air resistance. Air resistance is a force that's generated by air pushing against the object. Air resistance always acts in the opposite direction of the falling object. So remember we looked at vector diagrams. This is an example of a vector diagram. We've got our gravitational force being represented by that vector, and we've got our air resistance being represented by that vector going in the complete opposite direction. Now when the air resistance is equal to the gravitational force, their two vectors would be equal in length. And what speed has that object reached? It starts with a T, when air resistance is balancing the terminal velocity. So a skydiver, if they jump out of a plane, they will not continue to accelerate forever. When the force of gravity is equal to the air resistance pushing back up on them, then they've reached terminal velocity. They will not accelerate any further. They'll just stay at that speed. That's as quick as they can move. One famous experiment involved Galileo dropping two balls of different masses off the Leaning Tower of Pisa. He observed that the two balls landed at the same time and therefore must have experienced the same acceleration due to gravity. Interestingly, Galileo's work on gravity and motion marked the first time that mathematics was applied to physics analysis. So we will have a look at these questions. There are many gravitational forces acting on you from all the people and objects surrounding you. However, you can't feel the gravitational force on Earth. Explain why you can't feel the gravitational force of other objects. So I've already said this. Why was it? Why doesn't that bin start flying towards me? Because the force between us is small. Alright. Explain Newton's second law in words, in your own words. So this is basically just relating the direction of a force to the acceleration. So we know that gravitational force, if we drop something, the force is acting towards Earth, therefore the acceleration acts in that same direction. And we know that the magnitude of the acceleration will depend on the mass of the object if the force remains constant. So we've spoken about that already in class. Air resistance acts on all objects that are moving through the air. How could you reduce the air resistance acting on an object. Now, I'm not going to discuss that one right now because hopefully by the end of the lesson you guys will be able to consider some of the things that affect the air resistance acting on an object. Alright, so this is what we're going to do. This says this investigation involves dropping balls off of a ladder. We're not going to use a ladder, we're just going to use the balcony of the Turon. So someone must hold the ladder. Alright, we're not doing that. So we are going to have 2 heavy balls, 2 light balls, and we're not going to have a step ladder. Like I said, we're just going to be on the top of the balcony. The 4 balls should be similar in size to minimize the effects of air resistance. For example, two cricket balls and 2 tennis balls could be used. Now, again, they're talking about using the ladder. Wherever it says ladder, just imagine us being on the balcony. So, place the ladder on a flat section on the ground and have one person climb up to the top. So that just means one person's on top of the balcony. The person who isn't holding the ladder should pass the 2 heavy balls to the person on the ladder. So we don't need to do that. The person on the ladder should hold 1 ball in each hand at the same time, at the same height above the ground. An effective way to do this would be the face. So all you need to do is have the 2 balls out in front of you over the balcony. Release the 2 balls at the same time. Do not push the balls as you drop them. You don't want to push them because then you're applying an extra force. We only want gravity to be pulling those balls towards the floor. The person who is not holding the ladder should observe the pair of balls. So as they fall, try and see whether the ball. So basically for you guys, one person's going to be up on the top of the balcony, one person's going to be down at the bottom. You're going to drop the balls at the same time. The person at the bottom is going to see if they hit the floor at the same time. Simple enough. Alright. Try to see whether the balls hit the ground at the same time or whether one landed before the other. Record these observations in the results table shown below. Repeat steps 2 to 5 2 times with the same pair of balls. So basically, if you're doing a tennis ball and a cricket ball, you would do them at the same time, drop them at the same time, see how they go, and then repeat the process. Obviously, as we're dropping the balls off the balcony, make sure that people are well away from us. No one people passing by. If you see someone coming, just don't do the test until they're out of your way. So first you do it with a pair of heavy balls, and then you do it with a pair of light balls. So you might start off with a soccer ball and a basketball, then you might move on to a table tennis ball and a tennis ball. Alright, remember, for each of the pairs of balls, you're going to do it a couple times and record your observations. Alright, is there any questions about what you're going to be doing?